lastly, we've seen what is this? Continuous discrete, sorry, continuous distribution, right? Continuous this one, probability distribution, right? And that we have seen PDF and CMF, correct?
Yes.
CDF, CDF, yeah. Now we'll continue with that. Next, we'll be seeing distributions. Okay. Now we'll be seeing binomial distribution. Okay. So yeah, the mean median model, I'll take it in this. Okay, let's see first what is mean median mode, then we'll be coming to this binomial distribution. Okay. So okay. What is mean?
Average of the value.
Yeah. Mean is actually average of given numbers or the points which you are taken as a sample. So that is called as a mean. Then median is middle point or middle value, right?
Yes.
Correct. Then what is mode?
Most frequent value.
Yeah, correct. So let me give definition for these things: mean, median, and mode. So mean, it is also called as arithmetic mean, is it is the average of set of numbers. So mean is equal to sum of the all values by number of values available. Then median is the middle value in the ordered set, like it should be ordered. So for odd number of values, median is middle number. For even number of values, it is the average of middle two numbers. Next, mode. As we told, it is most recurring value, most frequent value. Set may have one mode, then that set is called as unimodal, or it may have two more or more than one mode. Then it is called as bimodal or multimodal. If it is two, then bimodal, or it is multimodal. Then, if there is no mode, then the values are very, there is no occurring values, frequently occurring values, all are equally likely. Yeah. Any doubt on this? Just go through this.
It's clear.
Okay. Now let's see. Yeah, you have more also. Standard deviation, other things also there. Let me take one by one. Yeah. So let me add some of these things here. So mean is also called as expected value, right? Expectation
Yes.
or expected value. So it is mathematically shown as mu is equal to e of x is equal to uh, x into p of x, or for continuous it is integration of x of p of x. Okay, that is from expected value. Now, uh, so median is something like the cumulative one which we seen, right? For any value which is having higher than 0.5, this one or something like that. That we'll see in the problem. And mode. Uh, so for this is for discrete one or more occurrence. Okay, this is a discrete definition. The occurrence for continuous it is so for the f of x which is maximum. Okay, so for any probability density function, any value in the PDF, any value in the PDF having f of x maximum. That is called as mode in continuous sample space. Okay. Next,
Yes.
variance. All are important. Variance is also denoted as sigma square. That is expectation of square deviation of a random variable from its mean. It represents how much data is spreaded or dispersed in the space. Okay, something like what is the how I can say how much it is scattered in this way. The data points among them, how much it is scattered in the space that we get through variance of data. That is taken through variance of x, random variable x, that is equal to expectation of it is random variable minus mu whole square. That is actual formula is expectation of this one random variable minus whole square of expectation. The difference between the square deviation and the mean is called as a variance. Next, we have standard deviation. Next, standard deviation. It is sigma. It is square root of the variance simply. So it says the average amount of deviation from points to the mean. Okay, so how much the points are away from the mean value, that is taken as an average for everyone, and it is given in this standard deviation format. So suppose here if it is the mean, suppose there is a distance between this, some distance we are taking, it is positive always, and here there is another point, some other distance, some like that. So how much it is scattered, that we get through standard deviation. So it is sigma is equal to root of variance. Okay. Next, any doubt in these things? These are basics,
Yes, sir. It's
right?
clear. Yes.
Okay. Next, coefficient of variation. shortly called as CV, is the ratio of the standard deviation to the mean, useful for comparing variability across different units. This we'll see in the problems. So not an important one, but still sometime they ask. Next. Yeah, this is important. Quantiles and quartiles. Quartiles. Okay. Quantiles is not important. Okay. Quartile is important. Okay, let's see. Quantiles and quartiles. What do you mean by quartiles? This one? Have you heard of about it?
Yes, sir. We like partition the data into four equal.
Yeah, 25%, 50%, 75%, like that. So
Yes.
how much it is like how much data is there in that percentage? We'll be checking out what is the gain in each partition. Okay, where it is more dense, where it is more this one which is not having much data, right? That we'll see through this quartiles. Okay. Now, 1 second. What do you mean by quantiles?
I don't know, sir. I'm not sure.
It's this we've seen already in this one CDF. So okay, let me show you that. Quantile is the pth quantile is the value something like p of x less than that point. So it is a cumulate. So it is the what I can say is the cumulation of all the probabilities below that p point. Similar to CDF, right? We have seen this. Like we are taking a accumulation or we are taking a summation of all the probability which you have below a particular value. How much it is covering? It is again a covering value, right? But we have not specified into 25% like that specific. Here we are taking some random point below that. How much we are covering, like that. Okay. So suppose something like if I consider Bangalore, how much people are literate? Suppose I'm getting 70%. Now I'm increasing the range like Karnataka. So now how much people are literate? It will reduce. Then I grow like that. So there is no specific partition. If you talk about specific partition, it is something like states, Karnataka state, Maharashtra state, or any other state. But if I'm talking about quantiles, then I'm defining the area for you. Like it is a state, it is a city, it can be city, it can be village. Below that, in that defined what I can say zone, how much probability we have, like that we are considering. I hope it is clear.
Yes, sir. Yes, sir.
Next, quartiles. So it divides the data into four parts. It is majorly used in company evaluations, how the company has performed in the quartiles, like that. So because we have 12 months, 3 months is a one quartile. So that is the economics. So yeah, it's Q1 is 25% of quartiles. Q2 is 50%. It is the median also. And Q3 is 75%. Like that. Okay. Then we have interquartile range called as IQR. It is simply the difference between highest quartile, that is Q3, minus lowest quartile, Q1. Skewness and kurtosis we'll be seeing later this. But any doubt in here?
No, sir.
Okay. Let's take some question and solve. Suppose some small example I'll take. So a data set one, two, 3, 4, 7, 9. Compute. One is mean, second one median, third one mode, fourth one Q1, fifth one Q3, then sixth one IQR. Yeah, solve this.
Sir, mean 4,
Okay.
median 3,
Hmm.
mode 2.
Hmm.
How to find the quartile Q1 and Q3?
1 second. So there is a formula. Okay, I didn't give any formula. Let's see formula first. It is so it is for Q1. It is n plus 1 by fourth value. So it is for 50, it is n by 1 by 2 value. For this, it is 3 into n plus 1 by fourth value of the data set. How many values are there in the data set? N is how much? 7 it is. So it should be,
7.
yeah, like that.
So Q1 is 2,
Hmm.
Q3 is 7, and
Yeah.
IQR is 5.
Okay. One more problem I'll give on this. Okay. Find the same thing for the this set, data set. For 4, 7, 8, 10, 12, 13, 15, 16, 19.
Sir, is mean 11.5,
Yeah.
median 12.
Hmm.
There will be no mode, right? Because
Yeah, it is very much scattered. There is no more.
so for Q1 it will be 10 divided by 4 twice. Take the third
Uh,
value,
so n plus 1 by 4. How much values are there? 3, 6, 9, right?
9
10th by 4, how much it is? 2 point something, right?
point 4.
Do you take the 2 itself?
Okay. So for Q3, the value is 7.5. So can I take the seventh value?
Yeah.
Q1 is 7, Q3 is 15,
Hmm.
and IQR is 8.
Okay. Fine. Any doubts in this things?
No, sir. No.
Okay. Okay, now I'll start with the distributions. First, we'll be seeing the binomial distribution. So, do you know binomial distribution is under which category? Is it discrete or continuous?
Discrete. Sir.
Discrete it is, right? So, let's start with distributions. So, why we need distributions? What I told when we were talking about distribution, why we need distributions?
For particular scenarios, according to that situation, we can find the probability.
Pattern I'm talking about, like particular pattern. If it is, suppose I have a question like we have tossed a coin for 3 times. This I can write the sample space, correct? But what if I just say like I have tossed the coin 6 times? So it is a considerable amount of sample space we need to write. Take days. So leave 6, 5 itself. So suppose if I have 3 times I have tossing a coin and probability of getting 2 hits. That is these 3 things: SHT, STH, and THH. That is 3 by 8 is the solution. You just gave this solution. But if I ask a coin tossed 10 times, then I need the answer for 5 hits, getting 5 hits. Right. So 10 times means 2 power 10 possibilities. That is 1024 possibilities you need to write. Then it should search how many having uh, 5 hits, right? So it is a considerable amount of time for these things. So what we use is we use distribution. So there is a common pattern is following up in different. So number might be increasing, but the pattern is same. It is either head or tail. So that pattern we are taking care. That is we call it as what is this uh, two-way classification or binary classification we call. So either it is either true or false, like that condition it is. One of them will definitely get. So in this condition, we just take the pattern and we be solving through the distribution. Okay, some behavior we are trying to capture. Now, let's see how the binomial distribution is behavior is captured. For binomial distribution, the conditions or the behavior is one is all the trials should be independent. Second is the number of trials, that is n should be finite. I can't say I have tossed a coin infinite number of times, then what is the possibility of getting 5 heads? I don't know. It should be finite. Next, third thing, the probability P of success should be same in each trial. So it should not change. That's what I'm saying. In the first trial, it was 50%. Second trial, it has become 13%. Third trial, it has become 20%. Such question we can't take. But here in cost toying, sorry, tossing a coin, in that the probability is same in every toss, right? It is 50% itself. It can be 10 times, 100 times, lakh times. But the probability of getting ahead is 50%. It is not changing. It is not getting influenced because of the trial. So all these conditions are satisfying with the our cost toying. Sorry, tossing a coin. So we can use this binomial distribution in our coin tossing, right? So the binomial distribution, the probability mass function is PMF here. It is not PDF. It is discrete. So that is P of x is equal to MCX into Px into q power n minus 6. N here it is number of trials. P is probability of success. Q is probability of failure. And P plus Q will be equal to 1. Q is equal to 1 minus P. This is known thing. So let's solve the same problem, getting 2 heads in 3 times, right? Using binomial distribution. Let's see whether we'll getting a same solution or not. Before that, is it clear what I'm talking about?
Yes.
Now let's see whether we get 3 by 8 itself here or not. Like probability of getting two heads. When a coin is tossed three times. So here number of trial is 3. Probability of success is 1 by 2. Probability of failure is also 1 by 2. Then P of x, the PMF of binomial is 3cx 1 by 2 x 1 by 2 3 minus x. I want two heads, right? I want P of two heads. Just put in the place of x 2. That is 3c2 1 by 2 power 2 1 by 2 power 1, it will become 3 minus 2 is 1. This is 3c2 into 1 by 4 into 1 by 2. This is 3 factorial, 1 factorial into 2 factorial into 1 by 8 it is. That is, this value is 3 itself, right? This value will become 3. Take it out by 8 it is. That is the answer. Correct?
Yes.
Similarly, I told getting a 5 heads. When a coin is tossed 10 times. Similarly, you can apply and you can get the answer very easily. That is, here also success is same, failure is also same. N is 10, it will become. So it is just P of 5 you should find out. That is 10cx 10c5 1 by 2 power 5 1 by 2 power again 10 minus 5 is 5. This if you find out, you'll get the answer. So distributions help us in these cases where the pattern is same, but the sample space is large and the occurrence of items are large. Okay. Hope I made this clear. What is the distribution and what is the requirement and what is binomial distribution? Clear?
Yes, sir. Yes.
Now let's see some problems. A minute to also see the mean and variance of binomial distribution. Let's see that. Okay, I'll generate the mean. Okay, you just see this. Not required, but still, you should be knowing how it is came. As I generate the mean rather than giving the direct equation. Okay, so mean and variance of binomial distribution. So what is the PMF? It is NCX PX Q power n minus x. What is the mean formula? Expectation formula? Not that mean, expectation I'm asking about. It is summation of n is equal to, sorry, x is equal to 1, 0 to n, x px, right? This I gave, expectation formula. Correct?
Yes, sir.
Now I'll substitute that PMF here. X is x itself. So in this place, it will become Cx p power x q power n minus x. Now let's see what is NCX, that is x itself. This is n factorial by n minus x factorial into x factorial into p power x q power n minus x. And here, what I can do is I want to cancel this x. That's why I'll just expand this x like n factorial by n minus x factorial I can write this as x into x minus 1 factorial. Is it correct? Factorial, I hope you know. This is maths.
Yes, sir. Yes.
So this cancel out. Then we have, I can also write like n into n minus 1 factorial, right? And below n minus 1 into, okay. Okay, this I'll just change it to n minus 1 minus x minus 1 whole factorial into x minus 1 factorial. Is it correct? Uh, yeah, finally you'll get the same equation, right? Here also I'll just expanding it. I'm just reducing it one quantity for everyone, every case. Okay. No need for you. Nobody will ask you for this one. Proof. That's I'm just simply I'm doing for understanding. I'll just take this variable outside, and this will be inside like x is equal to 0 to n minus 1 factorial by n minus 1 minus x minus 1 factorial into p power x minus 1 into q power n minus 1 into x minus 1. So this is actually equal to p plus q power n minus 1, where p plus q is 1. So this will become NP. So expectation of binomial distribution is NP. Okay. Just through binomial theorem, we'll be seeing that. Okay. Doubts? I hope I'm audible.
Oh, yes, sir. Yes, sir. No doubt, sir. It's clear.
Okay. That is this one that uh, derivation is not required. Just I did for me. I'll not do for anything else. Just for showing you, we are getting it through the definition itself. Okay. Next, the variance. I'll just directly give you the formula. It is npx. npq. Sorry. So just a hint. So in the problem, they'll not be mentioning which one you need to use, which distribution. You can use any. Just a hint how to understand where to use binomial. First hint is n should be small enough. Small, I'm saying like not 1, 2. At least it should be before 10 because else you can't find out n factorial and all. So NCX and all you can't find out. It should be considerably small. And P, the the probability of success should same, and it's almost near 1 by 2. It will be almost near. Yeah, that is the hint how to understand which problem, for which problem we should use binomial distribution. Let's take a problem. Can I take problems?
Yes, sir.
Okay. The probability that a man aged 60 will live up to 70 is 0.65. A man age who is 60 age now, he will live up to 70 age. The probability is chances is 0.65% or 65% out of 10 months. Now find the probability. One is at least 7 will live up to 70. Second, exactly 9 will live up to 70. And third, at most 9 will live up to 70. Let's see one by one everything. What are the given things here? There are 10 months. So n will be 10 and probability of success is 0.65 and failure will become 0.35. 1 minus 0.65. Sorry. What is the PMF? It is NCX Px q power n minus x. That is 10c x into 0.65 power x into 0.35 power 10 minus x. First question. At least 7 will live up to 70. That is at least this. So it is P of x greater than or equal to 7. More than 7 they are meaning. More than or equal to 7. That is P of 7, P of 8, P of 9, P of 10. Find out and let me know the answer for this.
So 0.5138.
What is the answer? Let me check. How much you got?
Point 5138 something.
Yeah, 0.5139. Next, second one, exactly 9, right? So it is P of x is equal to 9. Do it.
Point 0724.
Okay. Yeah, 0.0725. Third one, P of x less than or equal to 9. At least, at most 9. That you can write like 1 minus P of x greater than 9. This 1 minus greater than 9 means x is equal to 10. That's it.
So 0.986.
Yeah, 9865. Will you do a problem?
Yes, sir.
Okay. Here P and Q are both 1 by 2, 1 by 2. Equal chances.
So here we are taking 5 as n. Right.
Yeah, N will be 5. One of them you should consider. If you should consider X as either boys or either girls, not both. That you should follow throughout the problem. Then you'll get the correct answer.
Okay. So the first one is the answer 250.
Correct.
Second one 25.
Okay. Next.
Third one 500.
Hmm.
Fourth one 650.
Fourth one is
650.
okay. 650.
No.
Mm, okay. Okay, I'll check it. Okay. Fine. That's next problem. I hope you're understanding binomial distribution. It is not difficult.
It yes sir. I got it. I got it.
Okay. Other problems. Let's do some 3, 4 problems. Okay. Next question. Yeah, do it. Done.
No, sir, just a minute.
Okay.
Sir, it's actually a bit long. So.
Okay. So okay, do it one more. I'll give. I'll take it as both as homework. Okay.
Okay, sir.
So I'll give answer for both so that you can verify it. And if you are not getting, then we can discuss. This is for first one. Second one is 0.1600. Third one it is 0.8148. Here for this answer is 0.0355, 0.8713, and 0.9905. Okay, take a screenshot or something. You can just take this as a homework.